Okay, today we're going to talk about one more property. It's called closure property. Closure property is if you're performing an operation on any two numbers in a set, always results in a number that is in that set, then the set is closed under that operation. So that's pretty much the definition of it. I'm going to see exactly how it works when we do an example, but take a note of these two words, any and always. They're very important because this operation has to be able to be performed on any two numbers in that set, and it always has to result in the number that is in that set. So if that happens, then the set is closed under that operation. If it doesn't happen, look at the bottom here. If there is no closure, the test case will be called a counterexample. Now, in order to test this, first you have to identify the set of numbers and the operation in the closure question. Next, you have to choose two numbers from that set and perform the given operation on those numbers to check for closure. So, let's take a look at it. Let's take a look at a couple examples. I know right now it probably sounds like a bunch of gibberish, but it's actually pretty easy. So, let's go ahead. Okay, so for example, is the set of whole numbers closed under addition? So first of all, you have to identify your set. Your set is whole numbers. I'm going to use my shorthand here. Whole numbers. Now, what does whole numbers mean? Whole numbers are the ones that start, if you remember the bubble diagrams back from section 1, they start from 0, 1, 2, 3, and keep on going forever in the positive direction. So you're not going to have any negative numbers in the whole numbers set. The operation here is addition. So addition. Now to check this, I need to choose two numbers from the set of whole numbers. So you can choose 0, 1, 1, 2, 0, 3, 500 and 400. Doesn't matter as long as they're not negative and they're not fractions or decimals. So you have to choose numbers that only belong to the whole number set. So for example, I'm going to choose, I don't know, 1 and 3. So I'm going to do 1 plus 3 because 1 and 3 are both in the whole number set and the operation is addition. So 1 plus 3 is 4. Does 4 belong to this set? Yes, it does. If it would keep going, it would be 4, 5, 6, 7, and so on. So 4 belongs. So the result is that it could be, so the set, this is where you have to do some writing, the set of whole numbers could be, and pay special attention to this, we're going to talk about it in a moment, could be closed under addition. Now, why are we saying could be? Why aren't we saying that it is closed under addition? Well, are we going to be able to test every single example out there for all eternity? No. So that's why we cannot make a blanket statement like it always will be. So it could be because we tested an example, it worked, so it could be. We're not going to take our, we're not going to make a statement, a strong statement like saying, oh yes, we know that it will always be closed. But it could be closed. We can't prove it right here. Okay, let's try another one. All right, is the set of whole numbers closed under subtraction? Again, my set is whole numbers. I know that my whole numbers are like 0, 1, 2, 3, 4, and so on. And the operation is subtraction. So I'm going to pick two numbers and I'm going to check it. Now, for example, I'm going to check, now remember the order matters for subtraction. I'll check, 2 minus 3. How about that? 2 minus 3, positive, negative, different signs, subtract and keep the sign of the bigger, so my answer is going to be negative 1. Now, does negative 1 belong to the whole numbers? It does not. Negative numbers do not belong in whole numbers. So the result is no. So the set of whole numbers is not closed under subtraction. Okay? Now, we cannot tell for sure that it is not closed because even if we find one example when it doesn't work, it's no longer closed anymore. Okay? So here you can make a blanket statement saying that it's not closed because this didn't work. All right, let's move on. Try this one on your own. I already set it up for you here. Just fill it in, and then I'm going to do it for you in a minute. And our answers might be a little bit different the way we do it, but we should come up with the same answer at the end. So give it a try, and we'll see if you got it right. Okay, so I'm going to identify my set. My set is integers. My integers are like negative 3, negative 2, negative 1, 0, 1, 2, 3. You don't have to write that every single time, but this is just for me to show you what kinds of numbers we're dealing with. The operation is addition. So let's check it. I'm going to make it fun, so I'm going to choose a positive number and negative number. So how about I'll do negative 3 plus, because I'm adding, plus 2. Negative number, positive number, so I'm going to subtract and keep the sign of the bigger. I'm going to end up with negative 1. Does negative 1 belong to the set of integers? Is negative 1 an integer? Yes, it is. So I'm going to say that set of integers can, or I should say, could be closed under addition. Okay, so you might have used a different example, but this answer, your result, should be the same. Let's try this last one. Try it on your own, and then we're going to come back and check if you got the same result as I will. So it's the set of integers closed under division. So my set is integers, my operation is division, and I'm going to check. So again, integers are like negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, so on. I'm going to choose 2 of them, and I'm going to try dividing them. So let's see, I'm going to try dividing 3 divided by negative 2. Okay, gonna do long division. 3 divided by 2 goes in ones, minus 2, 1 is the remainder. Why not? I'll keep on dividing it some more. So goes in 5 times, minus 10, 0. So I ended up with 1.5. And furthermore, it's negative 1.5 because positive divided by negative gives me a negative answer. Now, does 1.5 belong with the integers? It does not, because integers do not have any fractions or decimals in them. They can be positive or negative, but they cannot be fractions or decimals, and this is a decimal. So the result is that the set of integers is not closed under division. Okay? Now you might have tried something like, 2 divided by 1, and you still would have gotten 2. So then your answer would have been, it could be closed. But if you tried another example like this one, because you can see that you can divide some numbers here and not get an integer. So if you try one of those like I did, you will get that the set of integers is not closed under division. So that's it. We're going to practice it more tomorrow, and I will see you then.